welcome to our second ever stream. So this is exciting. I'm Chris, I'm a lighting designer, and we have...
I'm Jim from RC4, the product designer.
We'll answer questions as we go, and yeah, make sure you ask the questions. You know, Pixel and Pixel Control is exciting. It's extremely useful technology, and but it can be kind of daunting at times, especially if it's your first time handling it. So we're gonna go through that stuff. Things that I use Pixel technology for is one, obviously set pieces. We've got a show 5 and Fire. It's running in Oregon right now. It just opened, where we have, I think it's 450 feet of pixel tape across the entire set. We're about 20 universes of data within there. It reacts to the artist singing on stage. It's interactive, creates energy, motion within there. I've used pixels quite a bit in fires, like fire pits and things like fireplaces and stuff like that. So you can create that motion and energy in there. It works great with torches. We've put pixels into quite a few costumes now at this point, so you can create energy and magic within the costumes. You can actually put pixels inside of daggers. There's production of Macbeth right now, where we have 24 daggers that have 28 LED pixels inside each dagger that are flown over the stage. They fly up and down, and it gives us the ability to run video animations, the actual video content through the dagger throughout the show. Again, that's all through wireless technology using RC4's DMXpix micros to do that stuff. So it's a very useful tool to find different ways to create art and to communicate your story within there.
I'll just say a lot of what you're talking about really depends on the small size. So that's really been my push for the last few years, is to try to make things that are wireless and draw very little power on their own, and of course run reliably. And we've added some of those other features that we'll get to later in the talk too. I'm proud actually to have a patent on part of this. That's our custom pixel profile system. So that gives us the ability to expand the data from a single universe in all kinds of very useful and visually stimulating ways to run up to 1,000 pixels, where a normal universe mapped 1-to-1 would only give you 170 pixels. So, 5+ times the amount of coverage, still with lots of creativity, entirely driven by your creativity on your lighting console. So it's not a pre-canned thing. It's a way to replicate what you're doing in a way that your console's been doing for you in the past. So, but the small, that's the thing I'm most proud of personally.
And that's a couple of really good points there. One, the fact that you can drive pixels wirelessly. As far as I know, RC4 is the only company for the entertainment industry that does wireless pixels across there. You can do it reliably. And also, you have to take into account what you're trying to do control and image-wise, right? So for 5 and Fire, for Macbeth, it's really important that I have detailed video going through these pixels. So I have to be a 1-to-1 patch within there. So for, let's say, 5 and Fire, a chunk of the set is off a very hardwired pixel driver because of the number of addresses and stuff and the amount of detail that we need. And then we had a section of the set where we added more LEDs and pixels to later. And the DMXpix was awesome because we were able to take it, just toss it in there, and all of a sudden we had wireless pixels and it worked. We couldn't get wiring to it and whatnot. And then there's times where you don't need that detailed in like animations and video. So production of White Christmas that happened this last fall, we had Christmas tree lights that were strung across all of these arches, hundreds of Christmas tree lights, and they're all LED pixels. So we could create animations back and forth. We could do different kinds of flashing effects, you name it. Well, we didn't need to be detailed. And so we took the DMXpix, which we're referring to this here. We took 4, I think, DMXpix units. We put them into the set. And I had a limitation of 3 universes, I believe is what the console limitation was, to be able to do these hundreds and hundreds and hundreds of pixels. And the ability for this unit here to replicate that data internally was a big deal. So we could still create the art, the motion, and energy that we wanted, just only on 3 universes versus having 20 universes. It's
another important part of that, the art and the energy, as you're talking about, is the real time aspect of it. So
yeah.
You can still black it out. You can like bring it down to a very subtle effect and then, blow it up at a key moment. It's all part of the scenes and cues of the show. All of that live stuff is well beyond trying to apply somebody's, pre-programmed effect.
And a good example of this would be when I light costumes. I have people ask a lot, why don't you just use Arduino cards to do the costumes? Why do you go with a DMXpix unit to do it instead? It's because during tech on the fly, when the producers or the director or the costume designer are like, hey, we like this effect, but can we slow it down? When this opera singer starts to come down a little bit and kind of slows down her pace and is taking that big breath, I can take the twinkling of the stars in the costume and slow those down and change the shape of that they move. And I can do it on fly in real time during tech, which is fantastic. With this Arduino card, then I have to take it, unplug it, put it in the laptop, put new code in, load it back on the Arduino, take the Arduino back to the costume, plug it back into the costume, check it, see if everybody likes it. If they don't like it, take it back out, go through that whole process. In tech, we can sit there with my programmer at the console, make these changes in real time. It is fantastic. It has changed, at least my methodology of lighting costumes, significantly.
Plus, Chris, you're part of that 2% of the overall user group that is comfortable to go and grab an Arduino. So as much as I encourage, because I'm an electronics product designer, I encourage everyone to go that way, to try it out and do a million things that are really cool. But sometimes you just need to grab a pixel driver and get the design done. And so I've packed a lot of what used to have to be done with an Arduino and given you a very quick, accessible path that's within the tool set that you are familiar with and that you use every day, your DMX console and your screwdriver.
Yeah.
Yeah.
So speaking of the DMXpix, let's take a closer look at it here. So this tiny box here, and they can come even smaller with a micro version. This can drive 1,000 pixels. So you can drive 1,000 pixels on output, or 500 pixels on output A, 500 pixels on output B. And that's all based off one universe of data. If you're using RGB pixels, you can do 170 pixels within one universe. Mm-hmm. And as you increase to RGBA, RGB, AW, you start to reduce the number of pixels that you can fit in that universe there. And the way that I recommend that you wire this up, you don't have to do it this way, but this is my recommendation, and Jim can correct me, is that I have my power coming from my power supply, which is currently on the floor there. My power's coming up. I'm splitting my power off to the pixels themselves. So these lines here are running to the pixels on the board behind me. And then I'm splitting the power off to the DMXpix here. Going to the output of the DMXpix, I'm only connecting the data coming out of there. That's the only thing I'm connecting. I'm not connecting the negative and positive. I don't need to connect those with them. That way I'm not putting that full load of the pixels through the DMXpix. And it's amazing how fast the amount of amperage that you're pulling can accumulate when you're adding more and more LEDs.
I always like to point out that that's correlated to voltage. So if you're running 5-volt pixels, which are generally the least expensive and easiest to get, they're a thing you can grab from Amazon and have your show up tomorrow. But at 5 volts, to get significant brightness, the amperage is really quite high. If you're running a 12-volt or a 24-volt pixel, then basically watts is amps times volts. So when you can increase the voltage, you can reduce the amperage. And amperage is really what a lot of our hardware is dependent on. Heavier wire for higher amperage. It's not heavier wire for higher wattage. That's the thing to keep in mind. It's amperage that matters for wires and connectors and all of the physical bits and pieces like that. So if you can run at higher voltages, that is keeping your wire gauge smaller and it's putting less strain on the connectors and the switches and all that stuff. So yeah, your current numbers can get very high, and you've got to take into consideration, this is with any pixel driver. This is not an RC4 thing, but with it's a basic electricity thing. But as soon as we're dealing with 5-volt devices, then we're dealing with high currents when we want to output a lot of light. So it's always important to keep that current issue in mind. A
good example, we have fairy pixels here. We have a disk of pixels. These are both 5-volt. And then we have a string of 12-volt pixels. These are bolt style. This is what's in the board behind me. These pull less amperage than these do, just because these are at 5 volt and the gauge of wire and the resistance within there. So these are more efficient amperage wise than this set's going to be. So knowing what you're putting into the device that you're trying to create makes a big difference within there. And with all things, we recommend that you always put fuses in line. My fuse is down by my power supply. But as a good example of what can happen, we don't put a fuse in. And this was something as simple as from the manufacturer of one of those discs, there was a little bit of solder going between the positive and negative. And this happened within a couple seconds. Plugging it into the power supply. It went into a 60 amp power supply.
But basically, we've had the wire conductors got hot, melted the insulation, and probably shorted together. Is that?
Yep.
So then, and then of course that short becomes like a secondary issue in the real load, becomes a very significant primary issue in the power wiring right there at the power supply. So that. This is why we always in electronics have to limit current to the wire gauge that we're using. What happened there was way more current was running through those conductors than that conductor wire and gauge size was intended to be able to pass. So this is why we have a fuse, so that when something like that happens, an excessively high draw, the fuse opens instead of melting the wire.
And this came off of a production. They were kind enough to let me take it and use it as an example. Now you can actually see there was a fuse here, and that fuse actually melted itself and came apart within there. This was a substantial amount of current that got pulled through this. Again, through a misstep in wiring. And that's why you put the stuff together, and that's why you put fuses in things. Especially if you're going to put pixels into costumes, you must put a fuse on those lines there. Keep in mind, as you put things, deal with more pixels and whatnot, you're going to have power injection. So every so many pixels for pixel tape with the bolt style pixels, with fairy pixels, you have to power inject every so many pixels down the line. When you put your fuses in, let's say we're doing a costume and I have 2 different batteries in the costume in order to power the entire thing. Make sure you have fuses on both set of batteries, because you may have a fuse on the main battery that's going to DMXpix in the beginning of the lines, but you have a second battery that's doing power injection for the rest. If you don't put a fuse on that, you're still going to have a current runaway. So
I always like to think of it as the fuse is to protect excessive draw at the source itself. So anytime you've got another supply of current, it needs to have a fuse on it. Around my shop, I have batteries with fuses permanently attached before. We have common connectors. This is in my environment. I'm not running shows. I'm doing product testing and, QC and stuff like that. But it's still very easy for us. We might get something back for repair that's got a short in it or something. So we need to be safe and protected all the time. But the whole idea is it's the power supply. I recommend everybody look at it this way. But what we do is we make sure that every power supply has a limiter, which is what a fuse is.
You can go power supplies and fuses and stuff like that. We should talk about the Phoenix connector and how to connect that up. So I'm going to flip my power off here to my DMXpix. And so this is your Phoenix connector here. And they can be a little interesting to deal with sometimes. And we have a lot of questions about them. When you're putting your wires into the Phoenix connector, make sure I can do this where you can see it. You take the wires out.
Let's explain even what you're doing there, Chris. I have sometimes had some customers receive the device for the first time, and they're not sure what to make of this connector. And it's a little bit my fault. I think I need to add a page to the quick start guide about this. I'm going to do that. But I guess my presumption had been that Phoenix connectors are quite popular and common, and many of my tech-savvy customers will already know what they are. But the flip side of that is Phoenix makes 90 different kinds of connectors, so they perhaps weren't familiar with this particular one. But yes, this is intended to be used with a stripped conductor. That is, it's not an insulation displacement. It is, you have to remove the insulation and then put the conductor into the hole. But it's sprung, so you press the orange button to release the spring, push the conductor into the hole, And then when you release the orange button, the spring kind of grippers grab onto the wire inside. So that's what's happening. So when you've got the correct length of stripped wire and you insert it in the correct length of stripping inserted into the hole, you can really pull and tug on that very hard. Phoenix has made a solid connector in that regard. But if you don't strip it long enough, or if the wire size is not within the range it's intended to be used, you might get into a problem. So some people consider or worry that this might be a kind of a fragile connector and you need to be timid with it. And that's not the case. You can hang some weight off that thing. I was actually revisiting the technical spec just today, and I was surprised actually that they specify 3 different applications for the same connector: solid wire, stranded wire, and ferruled wire. So after we finish this up, I'm going to put a link to the actual Phoenix tech specs. But you can insert a ferrule as long as it is of the within the allowed diameter range. And wire size, question about that. They recommend between sizes 26 and 20, I think. Let me just double check that.
Yeah, I think that's what it was. I have done 18 in there, but it's hard.
Yes, so in American wire gauge, AWG, its connector, the cross-section size is 26 to 20. And I know that we've got some non-North American users watching. So that is the 0.14 millimeters squared up to 0.5 millimeters squared. And also the length that they recommend that you strip off the wire is 8 millimeters. So that's the length they want you to have clear with no insulation to insert into that hole.
And I use these little grooves on here as a reference point of how far that strip back. I'll line my wire up to it and get a good sense of how far. And there's also a question, Jim, about is there a model or style you really like for fuses?
That's a tough one because the fuse you choose really depends on the specific application. The fuse that I might use is going to be different in a costume than it's going to be in a big set piece. And also, I may want to decide based on how easily I can get the fuses. So I actually have a personal liking of fuses that I can go to any local store and get, like automotive fuses. Because, you know, if I need to find one and I'm running short, I don't want to have to wait a day or 3 days to get more. It's really handy if they even got them at the 7-Eleven, you know. So that's definitely something that I prefer if you can use it. Beyond that, the world of fuses is probably something we could do a whole live stream about. So I'm going to just make a note of that.
Yeah, we'll make a note of that. So when you're stripping it, most of the time when people have issues, they're not stripping enough wire back. So I usually use this groove here as a reference point. Once you strip the wire back, I like to use a solid surface to press down on with the RC4 screwdriver or any object, and then you just slip the wire in there. I'm sorry, my fingers are in the way. Once it's in there, you can release that button, and then you can really yank. I'm pulling as hard as I can. I cannot get this to come out. If it pops out, that typically means that you do not have enough copper down into there for it to grab onto. I'm going to grab my positive here, push down on my little button. I'm going to slide it down in, make sure it's all the way in there, and I'm going to give a yank. And yeah, I can't get it to undo itself. So it is an extremely strong connector if you get enough copper down in there for it to bite onto. And then to release it, you just press and hold the button, and you should be able to release coming out of there. They're nice, solid connections. You'll also notice that I have another connector plugged in over here. So for our demonstration today, I just learned about this today. This is why I'm so excited. I have a DMX output coming from a DMX King node. So I'm running ETC EOS for our demonstration. Going to a DMX King node, I have an adapter that's going from 5-pin to 1/8" jack. I plugged into the DMXpix, and I'm actually using the DMX output as an input to bring data into the DMXpix to go to the pixels. And what that's allowing me to do is I'm also able to use the dongle and connect to Commander. So we'll be able to see both Commander and control the Pix from EOS, which I didn't know you could do that until today, and I'm beyond excited about this.
So just to summarize, on RC4 Magic devices, this actually doesn't apply to Lumen Radio and our LumenDimPix line. There are two simultaneous data streams that can be active at the same time. So one of them is the wired micro mini plug, which is wired DMX. And the other one is the wireless link back to, in this case, our configuration software, which is RC4 Commander. So Chris is able to bring in the channel data from his console through the wired connection at the same time that configuration can be adjusted and played with live using our Commander software. So it's not something you would do in a real show most of the time, but it is fantastic when you're creating your looks. So you're setting up for the first time and figuring out how to use, for instance, the custom pixel profile settings or something like that. So it lets you have the real DMX full universe and all the configuration parameters available for you to mess with at one time.
All right. So we're looking at Commander here, Commander 3.0, and we're connected directly to our DMXpix unit. You can adjust both outputs here. So you got output A and output B. So underneath pixel type, you can select a different type of pixels. You've got WS2812, which is your most common one, WS2801, which you'll need a clock line set up for that, and then continuing all the way through the rest. HD 108 is the only one that's 16-bit on there, right, Jim?
The MY, what is it? I can't remember what the numbers are. The MY something or other. It requires. Yes. So a few years ago, for some Disney projects, they brought that pixel type to our attention, and we added it to our firmware. And it was 16 bits, a very early player, really great looking also. Its clock line required an extra little bit of hardware to adapt it in a way that's unusual and that no other pixel actually requires. The HD 108 certainly has overtaken that. The MY part remains difficult to get if you can even get it at all. The HD 108 started off hard to get during the COVID years, but seems to be reappearing now with various suppliers. It's probably the newest pixel type anyway, but it is fabulously beautifully smooth dimming because it's internally 16-bit. And it's also a very high PWM rate, so it looks great on camera. It's, in my opinion, it's the best pixel to use right now in any kind of motion picture application. The APA 102 has kind of become the workhorse in the motion picture world for pixels. And its disadvantage that we've all suffered with for years is just like all the others, it's 8-bit dimming. It's actually a linear curve at 8 bits. So with LEDs, it gets very choppy. It drops and then kind of chops out at the bottom end. So you can't really smoothly dim it and get a nice look. So the HD 108 gets around that really nicely. The 16-bit dimming is smooths up the bottom beautifully. So if you can get it, I know a lot of motion picture people have been able to get it. It is the primo one to get. I want to mention too that although it does cost more money, the theater users and live concert users really should consider it as well, because I mean, more and more we're all designing for cameras now. Everything ends up streamed or recorded or promoted as video, and as soon as you've got pixels or any kind of imaging source in there that is strobing and creating artifacts and things on camera, that's distracting and less than beautiful. So I used to say, oh, if you're in motion picture, you need to worry about those high PWM frequencies, but the rest of my customers, human eyes don't mind, and it looks great. I've kind of retracted that now because, a lot of it had to do with COVID and everything being broadcast or recorded. So I think these issues now apply to everyone.
I've been using WS2812 or in that range for a lot of shows for a long time. Pixel floodlights, split lights, that works amazingly. And it's been great, especially because the budget wise, it fits a lot of the shows that I'm working on. And it's like back behind me right now on the pixel board, it looks fine, right? The fade looks fine because we have a lot happening on there. But as soon as you get to long fades, things like that, where you have just those footlights on that are fading out, and it's over 5 to 10 seconds, you're going to see that stepping at the end of the fade. And it's one of the things that I'm balancing now. Cool, so we can afford it at the moment, but maybe we should look at the investment for the future and purchase the nicer set of LEDs that can go to 16-bit and really get smooth fade. So now I'm sitting there parting out cues, trying to have the downlight on just a little bit longer to hide the fact that the footlights are stepping on their way out.
Yeah, I mean, that's the thing is right now pixels have become so popular as a substitute for any kind of LED tape, but it's kind of most of those items are playing like LED fixtures from 2009. That it's like they're technologically behind. So yeah, the HD 108 puts that sets that aside and catches up with the rest of the world in terms of how nice LEDs can really look and still be pixels. Yeah,
I can't wait to get my hands on some. I've been dying for that. We can also change color order, and personally, I believe it's best to set the color order correct in the DMXpix for the pixels that you've gotten, versus trying to do it in EOS or HOG4 or MA at the console level. Just set it correctly at the DMXpix itself, get the right colors there, and then you can just set your consoles at RGB or RGBA, whatever your standard color is for those pixels. Workflow wise, it just works better for me to do it this route.
The reason that's super powerful too, and I admit we're not the only pixel driver that gives you color order. It's kind of become standard now. Mm-hmm. It wasn't as common when I first coded it in the device because we've had it out now for a few years. But the great advantage of just doing all your programming as RGB and then adjusting color order in the hardware is you can swap, right? You can grab, maybe you've got a 2812 pixel string today that you bought on Amazon and it happens to be blue, green, red. But now you're going to swap it out, put something else in, or add another effect, double it up somehow, and you order another piece of pixel tape and it happens to be green, blue, red. So, you're going to have to duplicate the whole look in another group of DMX channels where the color order is different, or just tell the driver what's connected to it and run it on the same channels.
So we've got color order. We've talked about pixel type. You got setting your address. That's your starting address for that output within there. Remember, you can set A and B between the two different outputs. So you can set your order, and then you get into the fun stuff. The thing that makes the DMXpix what it is and why it's so incredibly powerful. Behind me, we have the pixel board back here. Right now, we're a 1-to-1 patch. So address 1 goes to pixel 1, address 3 or address 4 goes to pixel 2, and so forth down the line. That's how we're doing a pixel mapping effect in ATC EOS within there. But sometimes you don't have that much data, and you need to be able to get more specific in how you're going to distribute that data across things. And this is where the replication process is great. So in EOS, I'm going ahead and take us to a queue where I have 5 pixels on. So we have red, green, blue, amber, and lavender within there. Let's say I can only handle with either my console because I don't have enough attributes in the console, or I don't have enough universes coming out of the console. For whatever reason, I can only afford to have this many addresses being used. There's a couple different options you have. Option 1 is that you can change the group size of your pixels. So if I increase my group size to 2, I have 2 red, 2 green, 2 blue, 2 amber, and 2 lavender. If I set my replication by 3, first 3 pixels will be the same color, the next 3 will be the same color, and so forth down. It doesn't cost any extra addresses in the console. That's the great thing, is that the number of addresses is still the same number of addresses that we had for 5 pixels. And you can keep going. You can keep going up for the number of groups that you want to do, and we'll continue to add to it.
I just wanted to say, if you take this to the end, if you type in, if you group it to 500, which is the maximum number of pixels you can run on an output, then the entire pixel string responds to 3 channels for red, green, and blue. So then it's kind of like an emulation of a regular LED string.
Now what we're going to do is we're going to look at keyframe. That is extremely exciting within here. While I set this up, Jim, do you want to explain keyframe?
Yeah, so I borrowed the term keyframe from video language, but I've really pilfered it in kind of I'm using it incorrectly. So I apologize for those of you that actually work in data compression for video and know what a keyframe actually is. But I consider a DMX keyframe in this context to be a group of DMX channels that we use to represent the basis of our effects. So we might decide I can create the core of the pattern that I want to create with, say, 60 channels, or maybe it's 200 channels, or whatever it may be. And I shouldn't speak in channels, I should speak in pixels. So maybe it's 80 pixels. Remember, one universe is 170. So if I were calling the keyframe 170, then that's kind of the same as 1-to-1 on anybody else's pixel driver. But if we take, say, 40 pixels and we can create a nice looking effect with that, the RC4 driver now will replicate that in numerous different ways that we're about to discuss and stretch it out over many more pixels. But that basis that we're creating in the lighting console, that's what I call the keyframe.
We have our keyframe of 170. So that's saying that we are going to, on this output, do 170 pixels before it starts looping again. So if we had 175 pixels, let's say, and I had this entire universe on and I was set to a keyframe, it would hit pixel 170, and then pixel 171 would be the same as pixel 1. Pixel 172 would be the same as 2, and so forth. I'm going to set myself to a keyframe of 5 because I've got 5 LEDs across here. And we're going to set a keyframe of 5, pretending that we only have enough addresses to handle 5 pixels.
Which is 15 channels in a 3-color.
15 channels. And so we have 1, 2, 3, 4, 5, and then DMXpix loops us again. So now this pixel here is the same as 1, this is the same as 2, and so forth. And it just keeps repeating as you go through the entire sequence in there.
And it repeats out for 500 pixels. So remember, it's going well beyond the basic count of pixels that you would have got in an ordinary 1-to-1 map with a regular driver.
Exactly. And let's say if you're doing a, the old school 3-circuit chases that on the signs with incandescent bulbs.
The marquee effect.
Look. Yeah, the marquee effect. Yeah. And you can get, right over here, you can get pixels that look like these here, right? So these can be your marquee bulbs. Put them in there. And if you don't want to use a ton of addresses, you can just go ahead and set a keyframe of 3. And so every 3 pixels, it's going to replicate again, just like if you were doing a 3-circuit chase. So we have a keyframe of 5 right now, and we're replicating this way. So this one is the same as this one's the same as this one, and so forth down the line.
And I want to point out too that for this, just to demonstrate this basic concept, this is the most basic replication method, which is it's simply kind of echoing it along the line. It's copying. It's an incremental copy. So when it gets to the end of the keyframe, it starts again from the beginning, and then it plays through and starts again from the beginning. So that's one of several different options, but that's the most basic one. You know, Chris, if you increase the keyframe, say, to 6, then we'll get a dead pixel in between, and that might make it even clearer to see.
There you go.
So now, exactly.
Because I don't have anything on an EOS for this 6 pixel. Right. So that's why it's dead, and that can break it up so it's a little bit easier to see.
So that shows you the end. So one thing about that is the beginnings and the ends of the patterns sometimes can look a little abrupt, but they don't have to. It kind of depends on how you do the lighting design in the console. So one of my favorite lengths for a keyframe is 60. And the reason that I really like 60 is it divides by a number of different whole numbers. And that actually ends up to matter for all of the sort of sub patterns that you could create within the 60. So it divides by 2 and by 3 and by 4 and by 5 and by 6. And so you can create all of these things in the console that involve repetitions and patterns. And the seam, if you want to call it that, at the end of the keyframe will never appear to stutter or stagger because all of it fits within 60 without any odd end to a piece.
It's a lot easier to repeat without anybody noticing.
Yes, exactly. So, but one kind of fun trick, probably my favorite method for replicating is the one that mirror images and reflects back and forth. So it goes beginning to end, and then end to beginning, and then beginning to end, and end to beginning, and beginning to end. And that actually makes it look like the source keyframe is twice as long as it really is. And I just find that so, it's visually very pleasing. And it fits into the kind of look that we often get in any regular console that's doing an effects generator. The effects generation in consoles is actually based on many of these same ideas. They're just not necessarily sharing with you, how it's happening behind the scenes. You're picking things and applying them, but and then the console is doing all the replicating and using up all those DMX channels. And all we've done is taken that functionality and moved it out of the console so that it only has to worry about the keyframe, giving you back hundreds of channels and sometimes multiple universes that you otherwise had to, I'm going to say, waste on pixels.
And this is just the incremental repeat here. Let me switch to our next option. We can switch to decremental. I think that's how you say the word. And that's going to reverse those pixels. So you can see my dead pixels there. And we go lavender, amber, blue, green, red, dead pixel. So we're reversing the order that we're going in there.
You know where this works best, Chris, and it's actually the reason that I put it in there. It seems like it doesn't mean that much. But where it's really cool is if you have strings of pixels and you put two of them side by side. So if it's the same data running two side by side, and then you have one that runs forward in the pattern while the other one runs backwards in the pattern, you've suddenly got this added level of, once again, very symmetrical and pleasing pattern effect using the same number of channels. And whereas doing it another way, you'd have to double the number of channels you needed.
We can do incremental and decremental. So we go pixel 1, 2, 3, 4, 5, 6, and then it's going to start with 6, 5, 4, 3, 2, 1, and then 1, 2, 3, 4, 5, 6. Again, giving you more options of variety that you want to be able to do replication.
This is really my favorite. Can you make a little 5-pixel or 6-pixel effect now that runs in this? Because this has that sort of Christmas lights kind of. I'm going to call it a kind of a gaudy look. But, now if you do some really nice design limited to only 6 pixels, I'm sure Chris was going to do something that looks quite phenomenal for that limitation. But now imagine that we were working with a group of 60 instead of 6.
So this is just running a linear effect down the road, down the line there.
See, like already I feel like, man, I'm doing this with only 6 pixels, 18 channels. This is like, I'm not using an entire universe to do this. I'm doing this with 18 DMX channels.
Feels like this is something out of Studio 54.
Yeah, exactly.
Yeah.
Which was 1977?
Yeah. Yeah. Jules Fisher. And this is extremely easy to correct. I mean, it's a very simple linear effect on EOS with doing the incremental decremental setup on here, and we're using 6 channels that are RGB, so 3 addresses a piece. It's a simple effect, and if we change our format, so this is incremental decremental, If I go the other direction, it gives us a different feeling to it.
And if you had two panels side by side and one was the opposite to the other, you'd get an interesting sort of mirror-y thing going on too, which is really quite cool.
Yeah.
I've actually said a lot of the ways that that stuff works out well is if you're, say, doing LEDs on each side of a proscenium where there's kind of there's a balance going on, a symmetry once again. A lot of these tricks and effects work beautifully when you use their counterpart values on one side, so that then, once again, running it all from the same channels, the same like group or portion, subset of a DMX universe, you've got all of this action happening, complete with what looks like really some, well, to the trained eye, you know, well, those two sides are not actually the same because there's the symmetrical opposite element going on.
Mm-hmm.
But you didn't burn through channels to do it. The DMXpix did it for you.
And I'm going to go back to a keyframe of 170 so that we can just have a reminder that that's all my
That's
effect
all you're
is.
doing. Yeah, exactly.
That's the linear effect.
That's the entirety of the data coming from the DMX console.
Yeah. And all that is being brought into by setting a keyframe of 6.
And it's making use of that dead pixel, actually, right? Because
the dead pixel is currently in there too.
Yeah.
I'm gonna.
So, what is the matrix size that we're using for this? I've forgotten.
This is it's 100. It's 17 wide by 10 vertically.
Right. So it's one full universe in a regular 1-to-1 map. What if you did like a 16 pixel pattern? And keep in mind too, our visual appreciation of this is limited, of course, by the physical constraints of this panel being 10 by 17. You're often, when you're doing design work, you're dealing with a different layout in hardware to begin with, and then you'll be designing your effects and picking your keyframe size based on what you're actually visually presenting. And they often won't be a grid like this either. Like the proscenium idea, it could be 3 rows on an arch from ground floor to center of proscenium coming up in both ways, you know, so kind of this kind of look. The way that the dots actually appear in space isn't necessarily a grid.
You know, if you're thinking like a film set, something of that sort, the replication process would work really well if you're. I'm just going to use this as an example because I was watching it, the season finale. If you're working on a warp core, like say Star Trek, and you're trying to create motion and energy within there, we're doing pixels, but you don't have as many addresses as you want. You can use the increment decrement to be able to give that motion with a minimal amount of channels to do it. All right, so that is using 16. I'm still only using 6 channels on EOS that are currently on. So 5 that are the color and then 1 dead. Mm-hmm. And then the rest of the pattern here is because we're doing a keyframe of 16.
Right. So now expand the width of the effect in the console itself.
I'm just going down the line and adding a little bit of color to it. So this is using 10 channels in the console, running on the linear effect and having a keyframe of 16.
So 10 pixels, which is actually 30 channels. Is that right?
Yeah, sorry. 10. So white EOS is patched is 1 channel is 1 pixel.
Right.
And then there's 3 addresses per each. Yep.
Right. So 30 addresses, 10 channels.
Exactly.
Yeah.
Yep. So this ability to replicate is extremely powerful. I mean, it gives you so much flexibility with the minimal amount of addresses that you want to be able to use to create what you need. And there's nothing saying that you can't do a keyframe of 99 for 500 pixels or so.
Yeah.
You have complete flexibility. Within here, if you don't know what you want to start with, you have the option of going and using some of these presets within here. So let me sneak back what I'm doing on EOS here.
So I actually came up with these presets after messing around with the mostly in my mind, the theoretical math of how the channels and what I was talking about earlier, the number of different divisors that fit. But actually, try the versatile 30. I'm interested in seeing if you do that, and and then create a 30 channel effect.
All right, so I'm going to do the versatile 30, which is automatically going to enter the information into it.
Yep.
And let me add an effect back on.
And that's all it does, by the way, is when you pick those, as it says at the top, replication plan presets. All it is you pick one of these and it drops those settings into the data boxes to the left of it. So that 30 and 1, the 30 that's highlighted now, that's the 30 channels. And we've given you the option to create 2 that you really like, and that's what the bottom of that replication section is. Right, so that's the idea of just a marquee that uses 2 channels, and you create a 2-channel effect to chase around, a movie marquee or whatever that effect may be. A total of 6 DMX channels, or addresses, as you call them.
So now we're running an effect on EOS also on the console. It's a basic linear effect. So this is the marquee 2, we'll do a marquee 3. You can see we add into it a 3rd color. And so these are really good presets that if you aren't sure what you want to do or how you want to start with it, just try the presets and see what happens.
So this one with the marquee 30. The reason I picked the 30 rather than the 60 is because we've got a panel that's only 170 pixels in total. But if you, on the EOS now, if you create an effect that's 30 pixels wide. So remember all the time when you're looking at this panel, that panel is all the LEDs for what would normally be a 1-to-1 entire 512 channel, well, technically 510 channels of DMX. And just as a sidebar, the reason it's 510 is you can't have 171 pixels because you only have 2 of the 3 colors you need for 1 more pixel.
Mm-hmm.
So that's why we call a 1 universe map 170 pixels. You can have, red and green and no blue for 1 more, but nobody does that, obviously.
So this is 30 channels, so 30 pixels. Currently running a color and a linear effect on it with a marquee or the versatile 30 preset.
Right. So you're using, in terms of addresses, what I call DMX channels. Yeah. That's 90 DMX channels, 90 out of the full 512 available in a universe. And you're looking at a pretty nice pattern that normally would use the entire universe to put it on a screen of that size. That's a big savings. You're using 90 instead of 512. And you still have all the flexibility within those 90 addresses, the 33 color channels, to create an effect that is really still quite strikingly nice.
Yeah, it's actually working out really well.
Yeah, the 30 and 60 are one of my favorites. But where the 60 really shines through is what we don't have to show today, is that great advantage of being able to drive 500 pixels, right? So we're used to 1 pixel driver ending at 170 because that's the end of the data. Whereas now you can connect the end of a pixel string to the beginning of the next one and just keep on going till you get to 500. And this same effect will replicate, just like you see here, all the way along that. So, for example, you could have 3, maybe 4, my math fails me in my head right now, but, what would be 170 becomes 500 of that same look, effortlessly and seamlessly emulated across that much larger area. So that's the key, is you've created the keyframe replication thing is working really well here. Only 90 addresses.
And the nice thing is you don't have to do either a group or keyframe. You can do both.
Yeah.
So if I want to go to a grouping of 2, now we're into a grouping 2. And we can still have the same versatile 60 with the same setup and even less addresses because we're grouping by 2 within there.
Yeah. And really, it's pretty hard to tell, right? That now every pixel is 2 instead of 1. Mm-hmm. And so it's widened. If you had more LEDs to see, you would actually visually sense it as everything just got wide. And then if you put it back, it would get narrower. It's kind of it's the same effect, but just spread out or amplified in, yet another way. That's visually, it's best to see rather than to try to describe.
Are you telling me I need more LEDs in my office?
Oh yeah, you should cover LED walls all the way around and
everything.
Yeah.
Sure, we'll get on that. So
and it has to be HD 108 also.
Oh, I totally can afford that. Yeah, that's cheap.
We could start.
Yeah, this is the. Oh, I forgot. I was going to mention that you can. So we've done these settings here. Let's say I want to be able to recall this in a feature. I can just hit set, and then I can rename it or leave it the name that it is. And now I have this as a preset that I can always come back to.
Yeah.
So if I go and I click unison, so now it's all running off channel 1. And if I go back and click this, it'll go back to that preset that we just made.
So I think that we have quite a few LumenDim users that are dialed in with us today. So let's just quickly, we've really covered the features well here. I'm very pleased with how we've done that. But I want to now just talk about the accessibility of all of this stuff. If you're using LumenDim, the Commander software doesn't apply in that case. But what you do have is RDM access to all the same parameters. You don't have those presets and things because that's a convenience that we've put in our software. But you do have the ability to set the keyframe size and the grouping and the replication pattern. All of that is exactly the same. So although you can't do, well, you might have an RDM controller where you're creating the effect and doing the RDM control. And then you can get very close to what Chris is doing here with Commander. And it's all coming from one control surface, basically. But even if you don't have it set up that way, you could just quickly connect with a DMX CAT or whatever you want to use as the RDM controller, configure those parameters. Really, there's only 3, right? It's the size of the overall keyframe you're working with, and the way it's going to replicate when it gets to the end of that keyframe. So is it going to just repeat and start again, or is it going to mirror it back and forth? And there's a number of choices there. We've left a lot of room, by the way, to add more options as we develop the firmware. But right now you've got, what is it? 3 or 4 options in there right now. And then the third one is the grouping. So you can take that look and basically do the widening and the narrowing of it by picking how you're going to, group and how many pixels will be one virtual pixel. So with all of that, using RDM, the LumenDimPix gives you the exact same. In every other way, the LumenDim software is the same. The firmware is the same. It is actually the same code. It just doesn't communicate with Commander. It uses RDM.
And the Macbeth is using the LumenDimPix micros within there, and we used the DMX CAT to set them up. It was fantastic. As we walk up on set, we were able to plug into it, make sure the settings, addressing, everything's okay.
Yeah.
Unplug it, stick it back into set piece, move the OSIP piece, because it was an entire rig that flew up and down during the show, and it gave us a lot of flexibility.
For you guys that are using Stardust and the other leading stuff from Lumen Radio, soon we're going to see their RDM configuration via their web interface. So then you'll have that at your disposal. That kind of will become the equivalent of our Commander software, except it's tied right in there. All you need is a web browser connected to the Stardust, and the same features appear. And it's RDM, so we don't actually have to do anything. What we've already got in that device will appear in a graphical manner for you on a web browser. It's ready to go.
I wanted to point out real quick that this is the DMXpix. This is the DMXpix Micro. So give you a sense that if you need to put something in a costume or in a prop, let's say you have a sci-fi 3D printed gun that needs to go into a television show that you want to be able to have animations and video go through the gun and create that magical effect in there. You can fit something like this easily inside of a prop. This version just happens to have the external antenna. There are versions that have internal antennas also. And this comes in both LumenDim and in the Magic 3 series. And this is one of my favorite things because I can fit this in a fire pit. I can fit this in even a flashlight. I've done that recently too.
I think it's time to ask for questions. I'm excited actually about what you might ask me. Ask me a question.
Someone made a comment that at least with Supernova, I could see all of my wireless TXs in one place at the same time.
Yeah, and Lumen understands that the what's coming is actually vastly better. So of course nobody likes to be stuck in the little in-between window, but you're going to be very pleased with what they come up with. Well, maybe we've done a great job of answering everyone's questions.
Yeah.
Chris and I are both available even when we're not on camera. So, and I'm happy to answer questions. Our support ticket system is also for that. And I'm answering a great majority of them myself because I like to stay in touch with what people are asking and what they, it helps me figure out what the next product should do. So, linking key question. I actually have a prototype device on my desk right now that is nowhere near release yet, but it does support linking key. We can, right now, we can custom build a device that uses a TMO2 radio, and because linking key is supported by the CRMX app, that would let you right now do it. But our standard production right now uses the original TMO radio chip. So, I mean, yes, I can do it. I can do it right now, but it's not the product that we're making in quantity. So talk to me about that. If you definitely need it, we can make it happen. And it's not months of delay or anything. Like if you needed one next week, I could actually do that. So yeah, and coming in the longer term, all of our devices will support linking key. It's actually top of my list. I understand exactly why that's very attractive.
And linking key is specific to Lumen Radio right now, right?
Yes, it is strictly a Lumen Radio feature, and I believe right now requires you to be using a Stardust. I'm not sure what other transmitters support it. But yes, the idea is that you can turn off a transmitter or you can have a bunch of pieces linked to a transmitter and then go somewhere else with a different transmitter and all of the devices remain paired. You don't have to repair them to the other device. The linking key becomes the common element that keeps everything talking to each other. So yeah, it's kind of, if you think of how RC4 Magic IDs have worked for, 2 decades, that was really the big plus, is that you owned an ID and all your devices were on that ID. So then they just always worked. When you switch transmitters, they always work. So this was Lumen Radio's answer to that, if you will, because, competitors are always keeping up with each other. So that was their answer.
Thanks, everybody. Thanks for everybody saying that you appreciate the stream. We'll be doing another one coming up soon. We're working on figuring out the date and exactly what that one's going to be. And keep your eye out for more videos coming up. We have the fire pit videos almost ready to go. This Macbeth that we're using a Stardust with a bunch of LumenDim product in there. There'll be a video coming about that soon, and I'll share my thoughts about the Stardust and how it worked in the production and so forth. Hint, worked really well. And we'll be talking about the daggers and how we made video content across the daggers wirelessly and all that jazz. So yeah, stay tuned. You can always leave more questions in the comments and they'll pop up and we'll answer them. Even after the video's done, you can still leave questions in the comments and we'll get to them. Yeah. And yeah, thanks for joining us for our second ever live stream. We're still figuring things out, so we appreciate your patience.
And suggestions for new topics too. Chris and I want to keep doing this, and we want to deal with with concerns and questions and topics and subjects that matter to you. So the best way for us to know what those are is that you tell us. So please keep that in mind.
All right. Shall we call it?
Yeah. Thank you all. It's been a pleasure.
You all have a great day.
Thanks for joining RC4 Wireless. Make sure you drop a like, ring that bell, and subscribe to the channel to stay up to date with new tutorials coming out and how-to videos.